Our next presenter is Jonathan Nicolet from Universidad Nacional Entre Rios.
Hello to everyone. I'm glad to be here presenting my work that is entitled Classification of Atrial Electrograms in Atrial Fibrillation using Information Theory-Based Measures. Let me introduce you in this pathology. The atrial fibrillation is the most common cardiac arrhythmia, and it is generally linked to hereditary factors and to some non-cardiac other disease like obesity and alcohol consumption. This pathology is linked to the generation of abnormal impulse in the atrial wall that cause an abnormal function of the atria. It is clinically important, and the therapeutic strategies are not, have still some limitations in treating this pathology. So the objective of this work is applied some information theory-based measures to characterize atrial electrograms and to help in the classification of these signals. The database that we used consists on 113 atrial electrograms acquired during mapping in 12 patients, and these signals were classified by 3 experts in 4 different classes. These classes go from C0 to non-fractionated signals to C3, where the signals has more irregularity and were more fractionated. Only 68 of these signals were classified identically by the 3 experts. We will call to this subgroup of signals as reduced data set, and the full data set will be the 113 signals, okay? Let's see some of the signals representative of each class. This is a signal from class C0. You can see in red the raw signal, and in black the noise version of this register. Note that class C1 is more irregular than the previous signal, and in the next classes the irregularity increases. We applied several measures: approximate entropy, dispersion, Fusey, and permutation entropies, Salis, Shannon, and Renier entropies, and finally the Lempel-Zip complexity. Note that in each case we select some characteristic values in some of the features. As for example, in approximate entropy, we select the maximum of the approximate entropy, the H value corresponding to that maximum, and so on. 245 features were extracted in every signal, and later we applied a neighborhood component analysis to feature selection. The features selected in each case were tested in classification using 4 simple classifiers as linear and quadratic discriminant and linear and quadratic SVM. We tested with a 10-fold stratified scheme and applied the classifiers in 50 realizations. The results shows that the classification into 4 classes in the reduced data set obtains accuracies per class over 90% in every case, and the linear SVM was the best classifier in this case. looking for discrimination of C3 signals from the rest, we obtained the best results over the full dataset using quadratic discriminant, and in the reduced dataset, the best was the linear SVM. As the conclusions of this work, we can say that the most important features were dispersion entropy, fuzzy entropy, approximate entropy-based features, and Lempel-Sieve complexity. The classification of different classifiers was not significantly different. The performances were comparable in every case. And finally, these results shows the usefulness of information theory-based measures in classification of facial electrograms. Thank you for your attention, and we will see in the poster session.